We have already discussed transistors in the first part of this lecture. The way a transistor functions, it is easier to create NOT, NAND, and OR gates. A single transistor is required to create NOT gate, since NOT gates turn voltage low to low if it is high and high if it is low. This is exactly how a transistor functions, using its three terminals. Whenever input voltage is high or 1, source is grounded so that output becomes low or 0. If input is low or 0, source is not grounded, so it produces output of 5 volts, which is considered to be 1 in digital computers. NAND gate produces output 0 if all inputs are high. So to create a NAND gate, transistors are connected in series so that there is only one source and one ground. If inputs V1 and V2 are high, source is grounded, so output is low or 0. If any of the inputs V1 and V2 is 0, it will prevent source from grounding, so output would always be high. If both inputs are 0, output will also be 1. Output will be 1 as well. This is synonymous with working of NAND gate. NAND gate was created by combining transistors in series. NOR is created by combining transistors in parallel. NOR produces output of 1 if both inputs are 0. So in parallel, transistors output or source will be high only if inputs are 0, because if any of the input or both input became 1 or high, source will be grounded and output will become 0. These are the simplest gates to create. To create an AND and OR gate, we will need a third transistor which will function as NOT gate to the output. Circuits created with logic gates are of two types, combinational and sequential. In combinational circuits, output is dependent only on input values. In sequential circuit, output is dependent on the input values and current state of the circuit. Main purpose of sequential circuits is to store information. Memory devices are built from these circuits. Combinational circuits are created from various gates, and Boolean expression, logic diagram, and truth table also work for combinational circuits even if they are very complex. To create combinational circuits, logic gates are combined into circuits by using output of one gate as input to another gate. Circuit shown here has two AND gates with input A and B and input A and C. Their output D and E are input to OR gate, which produces output X. Output X will be 1 if D and E are 1. D will be 1 if A and B are 1, and E will be 1 if A and C are 1. Boolean expression for this circuit will be A dot B plus A dot C, or we can read it as A and B or A and C. Using rules of Boolean algebra, this expression can be reduced to A dot B plus C by taking A as common factor in both AND operations. Using this equivalent expression A dot B plus C, we can also reduce circuits to only 2 gates instead of 3. To show that circuit or expression are equivalent, truth table for both circuits are shown here. You can see the output X from first circuit and output A dot B plus C are equivalent. Using properties of Boolean algebra for AND and OR operation, we can determine equivalent circuits. AND OR operation hold true for commutative, associative, distributive laws. There is identity for both operation, 1 for AND and 0 for OR. Performing AND operation of a variable with its complement or inverse results in 0. And performing OR operation of a variable with its complement or inverse produces output of 1. De Morgan's laws are very useful in Boolean algebra. The first law states that NOT operation applied to the end of the two variables is equal to NOT applied to each of the variable with an OR between. Second law states that applying NOT to OR of two variables is equivalent to the NOT applied to each of the variable with an AND between. A binary adder is a circuit that performs addition of binary values. We will learn about two of them here. Half adder is a circuit that adds two bits and produces a correct carry bit. Truth table shows sum and carry after adding A and B. Sum shows exclusive OR operation between A and B. Carry shows AND operation between A and B. So XOR gate and AND gate can be used to create the half adder. Boolean expression for this circuit is easier to create. That is, A exclusive OR B is equal to sum, A dot B is equal to carry. A full adder is a circuit that takes into account the carry in value. It can be used to add binary values with multiple digits. With first two inputs, third input will be carry in, and outputs will be sum and carry out values. Sum of full adder is XOR function between carry in and output of XOR between A and B. From half adder we know that XOR operation between A and B is equal to sum. So if we take it as S, sum of the full adder is equal to S exclusive OR function with carry in is equal to sum, and carry out is equal to S dot carry in plus A dot B is equal to carry out. A multiplexer selects a single output from multiple input signals. For 2 power n inputs, n select lines will be available to select an output. So for mux with 2 select lines can show 4 outputs, and with 3 select lines can show 8 outputs. In sequential circuits, gates are combined in a way that allow them to store information. An SOR latch designed with 2 NAND gates can store 1 bit of information. In this circuit, there are 2 external inputs S and R. Second input to each gate is output of the other gate. You need to remember that NAND gate output is always 1 unless both inputs are high. Since output of one gate is input to other, so output X and Y will always be inverse of each other. That is, if X is 1, Y will be 0, and if Y is 1, X will be 0. So to store 1 in circuit, S is set to 0 so that X can become 1. And to store value of 0 in circuit, R is set to 0, hence Y becomes 0, and in result X will become 0 as well. Integrated circuits or ICs are complex circuits that are built by embedding or integrating multiple gates on the piece of silicon chip. According to the number of gates, ICs have been categorized as small scale integration, medium scale integration, large scale integration, and very large scale integration. VLSI or very large scale integration contains more than 100,000 gates. Using high gate to pin ratio, number of pins for both input and output can be kept low according to requirement. CPU is highly advanced integrated circuit chip in computers. This video completes the 4th lecture in computer science course. Thanks for watching.